center, because it's really the ends of the rods that are vibrating. The center's standing still. If you can microscopically see the vibrations, if I'm the rod, it's vibrating like this, up and down on the ends. The center's actually not moving. So if I rub it.
Mr. Janus, it's gonna break my glasses.
Oh, sorry. So you can hear the resonance of this rod. If I touch the end here, it stops, right? Because it's the ends that are really doing the vibrating. And so anytime, you can get air to vibrate somehow, you're going to get sound out of it. Now, stringed instruments work that way. Wind instruments might work a little bit different. Now, what you want to do in a wind instrument is send pulses of air through the atmosphere. And there are various ways of sending pulses of air down the atmosphere with the wind instrument. Now this is how sirens work. And what I have is a record here. And I'm going to hold it this side so I can see the lines in it. And I spent many an hour making this demo. Because I had to calculate exactly how far apart to drill these holes. And then in the process of drilling the holes, after I'd get a couple, say 100 of them drilled, I'd drill it and it'd crack and break the record in half. So after about 3 or 4 failures, I finally got this one where all the holes were drilled and spaced right to where, and I didn't break the record. So I'm going to turn this on here. And what I can do is blow some compressed air through this. Now what's going to happen is the air, as the record spins, this pulse of air is going to be blocked, and then a hole will come by, and the air will blow out, and then it'll be blocked, and the air will blow out. It'll get pulses of air.
That's a scale.
Now, this works okay. It blows out a little bit of air, and it's the scale.
Yeah.
And that's exactly it. The scale's a mathematical relationship of from one note to another. It doesn't matter how fast the record's spinning. It'll just be. It'll just boost it up a little bit higher pitch. Go a little higher. But this works okay, but what works even better is compressed air. I got this air compressor here.
Walker. Oh, I'm allergic to Walker.
Okay, this will be loud. That's really loud. Let me turn it down a little bit. Okay. Still too loud, isn't it? So let's see if I can get joy to the world here. Oh, and here's your siren. Let me unplug that. So you can hear as a siren works. In the old days, so inside of that old school siren, it used to be on police cars. It'd just be something that spins around and blows air through a bunch of holes like that. So let's see here. Try it again. Turn it up again. Get it going. Oops. I need to practice. Anyways, there you go. I need to work on this maybe before school and get it down a little better. But it's kind of interesting here how this works. That's why I needed to kind of see where the circles work, because that's where I blow the air to on this thing. So anyways, that's, and then I had to calculate out, I don't know if I have it on this sheet or not, I had to calculate the fractional ratios, how many holes go for each note. And if you're interested in that stuff, talk to Mr. Lawrenson, because he knows all about this stuff. Music theory is what this is. Now, one other thing we can do to get air to vibrate, this is the only one I have left that works. So let me get a couple torches. I need to, during my prep period, make fix these. So hopefully, yes. What's that? Oh, yeah, I'll have you help out. All right. Did you see this at back to school night? Yeah, that's right. Let's see. I've got this one. Now this, I don't fully understand how this works, to be honest with you. Like a lot of things in physics, the math all makes sense. But actually what's going on is very confusing. And especially an area of physics called quantum mechanics. Has anyone ever heard of that term before? Quantum mechanics? It has to do with the laws, the gravitational laws that dictate how planets move around the sun. And quantum mechanics is the set of laws that talk about how electrons orbit around the nucleus of an atom. And a lot of people say, oh, well, an atom's just like a little miniature solar system, right? You got the nucleus in the middle and things go around it. Well, that's just the drawing in the books. The reality is that they follow the electrons orbiting the nucleus, follow these absolutely bizarre, crazy paths that cannot be explained if what we talked about earlier this year, if our universe is three-dimensional, like we think it is, right? We're all sitting here, it's three-dimensional space. The only way the way atoms work makes sense is if our universe is 11 dimensions. There's the 3 that we're familiar with, and then there's 9 more that we have no clue how they operate. Actually, the 4th one we kind of know, but anyways. Craziness. This is kind of the same way. How this really works, I'm not sure. Mike, you want to be one of the pyromaniacs here? All right. Go ahead and just open that valve up all the way and pull the trigger. Come on up, Claiborne. You can be my other pyromaniac. Just open that valve up full blast and pull the trigger, okay? Yeah, open it full blast. Now what this tube is here, you can see it's hollow. Willow, verify it's hollow. Veronica, hollow.
Question.
You guys see that? There's nothing in this tube here.
Question.
Yes.
I'll show you a shoot.
Can you turn on the air? Can you turn on the heat conditioning because it's cold around the class?
I have no way to turn the heat up in here. It's all done by computer. So what we're going to do is we're going to heat up this little block here. And this block is, you can see through it. It's honeycomb, so it lets air flow through it.
Yeah.
And when I drop it in this tube, when it's really hot, it's going to cause the air to heat up and rise through the tube. And this block has to be exactly 2/3 of the way down the tube for this to work. If it's anywhere else, it does not work. That's the math of it that I understand. Go ahead and get this thing blazing red hot, you guys. Starting to blow pretty good. Alright, that looks pretty good. I'm going to drop it in the tube. And it's, now you can feel the vibrating air above the tube. You can feel it's creating pulses of air. Feel that? It's loud. You guys want to feel this there? You can feel the vibrations probably from where you're sitting, right? Crazy how this works. You guys want to get it going one more time? Get it going one more time, you guys. I'll see if it's working. I think the blocks are broken on it. These ceramic blocks are very fragile. And what happens is when they're red hot, they'll melt to the inside of this tube. And once they've done that, they just shatter. So my other blocks are shattered. I have to make new ones.
And then where can you buy these?
You can't anymore. I waited about 5 years, and somebody on eBay sold a couple cases of them, so I bought all of them. He had 5 cases for sale.
Where'd you get the which ones?
They used to sell them at Home Depot, though. You get those at Home Depot.
These you can still buy.
Yeah, you can buy those, but these ceramic blocks, you can use other materials for it. Metal screens work, but this works way better. Metal screen will only make noise for about 10 seconds, and it'll cool off. All right. Anyone else want to feel it? Come on up here. You can feel that hot air coming on out of here. Isn't that crazy? So if you turn it sideways, it stops. It has to have the airflow upright. The craziness here. It's just wild how loud that is, isn't it? Yeah, and that's the hot air coming up from the brick. So like move it. No, I don't. I even bought a book on the physics of wind instruments and read about how they work. The only thing that made sense to me, I'm just convinced the guy because he tried to explain how this works, and it made no sense at all to me whatsoever. The math adds up. It's like, hey, this is the formula to get the note G. I knew exactly how long to cut it and where to place it, but why it does it, I don't fully understand it. It's crazy. Yeah. I mean, it's so loud.
Yeah, like some significant sound comes out of it.
Yeah. The original thing I found in a book was you use a metal pipe, you take a torch with a long neck on it, and you put the torch inside the metal pipe and you hold it at a certain spot. And so I did that and made one. It kind of worked. And then I got the idea, well, how about if I just put something hot in the pipe? So I used the screen, and it worked pretty well. It worked better than the torch did. And then I was at Home Depot and I saw these one day, and I said, I wonder how they'll work. And they just work way better. I mean, I found nothing that works as good as those briquettes. So, anyway, so let's see if we get the big one going. Yeah, let's see if it's. Hold the pipe over there. See if I can hold this thing out. Oh yeah, I got one on here. Okay.
No way.
Let's see if we can get this one going. Let's see, Cambria, I'll have you hold the pipe here. Let me, you can stay right where you're sitting. And I'll hand it to you here, so you hold it. And when we get it hot, I'll slide it on in there, and then you can pick the pipe up. And I'll move this one down here. Go ahead and heat it up, guys. So once again, this should make a much deeper tone.
It's gonna break
Than the other one, yeah.
It's actually snapping off.
Yeah, what these are designed for, they're barbecue liners for gas barbecues.
Janus.
You line the bottom of your gas barbecue with it, and it evenly distributes the heat. So you don't have it really hot, burn your burgers over the flame kind of thing.
It's shaking, man.
It's breaking off.
Yeah, I see it's breaking. This one's just barely hanging together.
So conceivably, if you put something to work
Yeah. If the materials that you use for the 3D printer will stand heat like this. Really?
They have 3D printers already.
Wait, what piece is missing?
That's a really cool idea.
What piece is missing?
Okay, that's pretty good. Let's drop it in there. Okay, now hold it up in the air. There you go. It's not as loud as the other one, but you can feel it. See how long now? Thanks, guys. All right, thanks. Look how cold that bottom of that thing is, too. Guys, feel how cold the bottom of these are. Remember when air expands? So the air inside the propane was expanding and it cooled off. See how cold the air is. Oh, it's not super cold, but exactly when air expands, it cools, and there's an example of how cold things get. It was compressed in here and it expanded. All right, thank you, Cambria.
Wow.